Hi and welcome to the channel. Through this video session, we are going to learn about the DynamoDB. Firstly, we'll try to understand what the DynamoDB is, the various key concepts, the real-time use cases where DynamoDBs are being used. Then we'll close the session with a demo on it, where we'll create a DynamoDB and insert the data and play with some of the queries. So let's get started on what basically the DynamoDB is. DynamoDB is a NoSQL database, which means this is not a relational database. There is no SQL, the structured query language support here. This is there's no schema. There's no fixed schema followed by the DynamoDB. It is basically a document based. This follows basically the data for the data storage. It follows the key value pair internally. So all the data that you have to keep it into the DynamoDB, it must be formulated in the key value pair structure. And basically, the JSON documents are more suitable for storing the data inside the DynamoDB. DynamoDB supports multiple types of indexes. There are primary index and there are secondary indexes. Secondary indexes can be created as well. It has a support for multiple types of queries. We can do the queries different ways. It has the support for the streams and triggers. Streams are basically the live flow of the data, where you can apply lots of functions on the go. DynamoDB also offers a direct access from the API gateway. That means you can call a REST endpoint from the API gateway without Lambda function as well. It can be it can invoke the DynamoDB database basically from the API gateway directly. This makes more suitability for microservices basically. So DynamoDB can be used, or in fact, it's being used vastly into the microservices as well because of this feature. This database can handle more than 10 trillion requests per day. This is really a very performant system. The DynamoDB also supports the peak of more than 20 million requests per second. So in a peak hour, 20 million requests per second is the TPS that is guaranteed. But again, it depends on what is the item size, how do you design your database basically. So let's try to understand the key concepts, what the DynamoDB is based on. So firstly, there's a primary key. Primary key is a unique identifier of the records over here. So there's no records. Instead, we call it as items. So each item can be compared to the rows in the RDBMS loosely. So each row, each item is identified by a primary key. Primary key can be one column or one attribute, or it can be a combination of two attributes. The first one can be a partition key, and the second one can be the sort keys basically. So partition keys are basically a key that can be used for further partitioning the tables to multiple keep it as a multiple partition inside the database for ease of retrieval and for faster retrieval basically. So primary key can be a composite primary key, which can be combination of partition key and sort key, or it can be a partition key based primary key. So sort keys helps to store the data in a group wise manner. That means you can organize your data far better way. It's not necessary to always use the sort key, but wherever you have to organize your data in a group. For example, in this place, you have a product ID as one, and it can have a type as a sort key, which can be book ID. So all the different products which has a book ID as which has the type as a book ID can be taken as a one single unique data basically. So it can fetch the single item as a single item, right? So this is how effectively the sort key can work. Then you have a different attributes other than the primary key. So primary key and then the attributes. Attributes are different data entities, right? You can compare the attribute with a column basically in the RDBMS. There are a couple of good use cases of DynamoDB. One of them is Slack. Slack is a chatbot. It's a free open source chatbot which is used by mainly lots of organization uses it. So Slack can post the data event to the API gateway, and API gateway can trigger a REST call for Lambda function, and Lambda function can do the read or write operation on the DynamoDB. So for storing the data or consuming the data from the DynamoDB, Slack uses the DynamoDB basically. And this call can be via API gateway, which can be event driven, or it can be using the web APIs directly. Second use case is a mobile user can directly send the SMS, and Twilio can help to get that SMS. There is a service called Amazon Lex. This service basically facilitates the conversation over the SMS. So it can receive the SMS and trigger the Lambda function to save the data to DynamoDB or get the data from the DynamoDB. And this is like a fully automated chatbot use case basically. Third use case can be basically of Alexa, and Alexa can have Alexa device can have Alexa skills. Through that, it can invoke the Lambda function, and Lambda function can again interact with the DynamoDB for the various reason to store the data or retrieve the data or manipulate the data which is already there inside the DynamoDB table. And for that, there are a couple of assistance services like IAM, CloudWatch, and S3. So IAM can help to control the access, validate the user authentication authorizations. And CloudWatch basically writes all the logs. It collects the logs that is generated by Lambda function while the event triggers, right? So this is what the another use case of DynamoDB, and DynamoDB is being used for persisting the data basically of all the Alexa skills commands basically which is being triggered. Fourth use case can be the application has analytical requirement, right? So the analytics has to be shown in using the Apache Zeppelin, and Apache Zeppelin is the one of example for showing the dashboard of the analytics basically, but it can be something else as well. So in this particular use case, we are using the DynamoDB for generating the stream. So DynamoDB comes with the support for streams that's called the DDB streams. So DDB streams can be generated for any change or any update that happens in the database, and that stream can be redirected via Spark stream, and a Spark stream can further process that data towards the Amazon EMR basically. So Amazon EMR is going to apply some MapReducer function over it. So Amazon EMR is basically for Elastic MapReduce. So it helps to create the MapReducer functions, and once the MapReducer function applies, and the data outcome can be taken as analytics to plot the charts using the Zeppelin in the Zeppelin notebook, right? So this is one of the use case which is common into the analytics basically. There are several other possible use cases. Here is a combination of use cases basically, which is also very common to be used in the industry. So one of the use case at the right hand side down, the data pointer can trigger, or the client can trigger the upload, which can trigger event internally in the S3, and that can be further used to invoke the Lambda function, which can interact with the database for doing the operations like read, write, or delete, update, right? Such operations can be performed using this flow. One more is with the SNS. So SNS is a complete publisher subscriber based system. So SNS is simple notification services, which is responsible sending the email or SMS to the downstream systems by using the subscribers module, right? So the subscriber module can pick up that and use it for various purposes. So it can also allow the Lambda function to register as a subscriber. This originates from over here. So in the database DynamoDB, if there is some of the data which requires to be synced to the another set of DynamoDB over here, it can generate the data synchronization streams basically, and the Lambda function can be triggered to push it to the SNS topic, and SNS topic can be read by the Lambda function, and also many other subscriber can use the same changes. But importantly, the one that is subscribed over here is the Lambda function, which is responsible updating the data into the another set of DynamoDB. And this is the other common use case where you have a data streams which you pass it to DynamoDB and directly updating the another database. So this is also a data synchronization or data push to the another database of DynamoDB. So these are the common use cases. The user can directly invoke the Lambda function and use the DynamoDB for that purpose. So there are several use cases like that, and there is an endpoint created over here for the user which can directly invoke that REST endpoints of the API gateway and invoke the database for, again, the operations to be done like read, write, or update, delete. Such operations can be performed over here. So this is the combination of different use cases, variety of the use cases which is possible and being used at the industry level. So time for the demo. Let's get started with the demo, and this demo is going to be quick demo which will demonstrate how we are going to create the table inside the DynamoDB, and then we will upload our data into the DynamoDB. For that, you have to be logged into your AWS console management. And you should locate your service DynamoDB from the services, either from the database directly, or you can type over here alternatively So once you click on DynamoDB, you will go to the splash screen of the DynamoDB. You can click on the create table and give a name as a table name. So in this case, we are going to give a name as a product catalog, and partition key that we are going to use. This is going to be our primary key as well. So if we use the partition key and primary key in combination, that becomes a composite primary key. So I'm not going to use the sort key for right now. So the primary key is my partition key as the ID, and I'll choose the data type as a number. Um, uh, DynamoDB supports different types of data types, basically 10 to 12. Out of that, 4 or 5 composite types are there, and 6, 7 different primitive types are supported. So here I'm not going to make any change. I'll just go ahead and click on the create. It will just be created very quickly, so it doesn't take a lot of time to create the table, as we are not doing any data insertion at the moment. So this is the table that is created, and we can see the items, which is nothing but the table columns, basically, in other words. So here this shows empty, and we are going to now push the data to the product catalog table using the AWS CLI. So for that, I have already installed the AWS CLI, and you can follow my another video for setting up the AWS CLI, which is available in YouTube. Now I'm having my file called ProductCatalog.json, which has all the data. I'll just browse and show what I have. So it has a multiple items inside it. Product catalog, which has item, which has basically the information about the product, book, ISBN number, title, authors, such informations, the price, and different information about the book. Then a couple of more book informations, and then it has a different item. So this information is about the bicycle, and several combination of products informations are there in the product catalog. So you can see this is a JSON formation of the data, which we are going to use to push inside the DynamoDB that we have created, the table product catalog, right? So what prerequisites of doing this demo is to have the AWS CLI installed, and the AWS CLI should be configured. So we'll just verify how the configure has to be done. So once you install it, you hit the AWS configure command, and then from the IAM, you should bring the access key ID and secret key ID, basically. So here I have all set. So if you have not, then you have to download the access key, secret key, CSV, and follow the steps that is mentioned in another video. So we'll just skip the access key, secret key values setup. I'm in AP South 1, which is Mumbai region. You have to make sure you set up your region exactly same as where you have created your AWS DynamoDB table. So I'm in Mumbai, which is AWS region as a AP South 1. So I'm into the same region. So I'll just skip this as well, and output format as a none is well for me. So there's no problem in that. So this is something which is a prerequisite. You have to make sure that this works to complete the lab. And this file is in the path, so I am good to go. Next thing I'm going to do is I'm going to take this command from here, which I will explain in a moment. I'll take a command and copy this command, paste it into the command prompt where my AWS CLI is already configured. and environment variables are set to run the AWS command basically. So in the command, basically there are four parts. First part is AWS, which is the command of interacting with the AWS using the AWS CLI to AWS server. And this is the service name which I'm going to give it as a argument to the AWS command. That means I'm telling that I'm going to consume the service called DynamoDB. And thirdly is the operation, which is a batch write item, which is going to take bulk of product catalog informations and write it in a one go. And fourth one is the information which says that what kind of input or what input we are sending. So this is the request items, and which has the value as file path. So this file path is the file path of the file that I have shown you a little bit earlier. In line of command execution, we are giving the file path of the JSON because we have a bulk data to execute. But you can also follow, if you have a single data item, you can follow the inline JSON directly. You can do that. In that case, your batch write item will change to some other operation, right? So let's go ahead and hit the enter button and wait for so wait for the operation to complete. So this operation is completed with no unprocessed item. So there is a zero unprocessed item. That indicates that all the information that I have pushed through the ProductCatalog.json is accepted inside the DynamoDB and it's uploaded, and we have the data now available. So clicking on the refresh button over here, you can see the data is available. We have all the data properly coming and sitting inside the DynamoDB table. All right, so there are a lot of information which is inside here. We can add the filter and do a little bit of query part. So if I want to go for pricing of the pricing based query, so I can say price. If the price is between, or I can use the between. So between say maybe 500 to 1000, my data should be shown. So I should start doing the search, and this is the only item which has the price value as a 500. There's no other item which has the price value matching with this range 500 and 1000. So I can just increase the range to see if I have another set of data which is falling into it. No, so there's nothing. I can just decrease it to see that if I have some of the data, more data, which qualifies with the condition. So this is the one. I can also make it a little bit more down to see that if there are more. So yeah, so there are a couple of things. So this is what you can do. If I want an exact match, I'll say this, and I should see the one of the value. And if I want to do some other stuff like greater than, I can do the search this way. And if I want to add more filter saying that any item which has the price greater than 300 and but the product category is basically book. So if I want to do this search, this is what the exact match will come. So this is what you can do with your DynamoDB using the console management. But this is not the best way of using the DynamoDB service. So most of the time you will be using the Lambda functions, or you can also use the SDK libraries to directly call your DynamoDB table and interact with it. So there are several possibilities in the microservices. You can use the combination of API gateway and Lambda function, or you can use the API gateway directly. So these are the stuff about it, the concept about it. The schemaless, in this first three items, you see that there are only 4 of the attributes are present, including the primary key. Rest of the others are disappeared; they are not there. So the is there at the somewhere in the end of the items basically. So in middle of the item, there are some of the attributes missing, and this is what the benefit of using the NoSQL. It is not going to bother about the space for these attributes basically which is missing. So it's going to only store the data which is present. The rest of the data, the rest of the attributes which is not present, it's not going to reserve the spaces for. But in the RDBMS, since it's a RDBMS, it's not a NoSQL, so it cares about the schema. It reserves the spaces whether the data is present or missing. So that's about the one quick comparison about NoSQL and RDBMS. So once I'm done, I'm going to delete all of them because I clean up the resources to save myself from the bill. So this is what you should do as well. Once you're done with your lab, you should clean up. So that's all. I'll keep this command inside the description of the video. Hope you have liked the video. If that is the case, then please like it and subscribe so that I can give more videos to you. Thanks for watching.